All right, this section of notes is 7.3. So this is solving simple exponential equations. Okay, so equations that involve exponents. First question we have is, what if we have an equation involving exponents? So first off, the main thing that we're going to focus on is making sure that the base is the same. So if the base is the same, then the exponents must be equal. Remember, this number here is the base, this is the exponent. So if we have the base the same, then the exponents must be equal. Okay, in the first example here, remember if there's no exponent, then it's like this would be 12 to the first power. Since the bases are the same, the only way this would make sense is if 1 equals x, or in other words, x equals 1. Okay, it's the only way that these two sides are going to be equal, is if the exponents are equal. Okay, so if the bases are the same, that means the exponents are equal. Okay, looking at the next example, the bases are the same again. They're both 8. So that means these exponents must be the same. So I can say that x minus 3 must equal 4. Then I can solve for x by getting it by itself. So I add 3 to both sides and get x equals 7. Okay, these examples below, the first one's pretty straightforward. If 100 to the 6th power equals 100 to the x, then x must equal 6. Here the bases are equal, so it must be that 2x equals 6. I can solve by dividing both sides by 2. I get x equals 3. And finally, last one here, the 2's are both the same, so I get y minus 1 equals negative 10. I add 1 to both sides, that cancels, and I get y equals negative 9. Okay, so then the problem comes up if the bases aren't the same. So here we have 5 to the x equals 25. Okay, realize this is not 5 times x equals 25. Okay, remember our exponent means something different. It means I have 5 times itself a certain amount of times. Okay, whatever x is, x times. Okay, so what we need to do is we can't just divide, we need to make the bases the same. So 25, I'm realizing, well, that's just the same as 5 squared. So now I can write my equation like this. 5 to the x equals 5 squared, which tells me, oh, well, that's an easy problem now. The bases are the same, so it must be that x equals 2. Okay, looking at some of these examples where we have to do this. 27, I want to write it as a 3. If you think of your multiples of 3, 3 times 3 is 9. And then 9 times 3 gives me 27. So that's 3 cubed. Okay, and then once I have that, if the bases are equal, then I know the exponents must be equal here. Okay, I can solve by dividing both sides by 4. Those cancel, and I get x equals 3/4. Okay, the second one, 81. I know if I want to write that as a 9, I know that 81 is the same as 9 squared. Bases are the same, so I get that x equals 2. Okay, this is again 81, but now I want to make it look like a 3. So I have 3 to the y equals, I saw over here 3 cubed is 27. So if I do 27 times 3, that would be 3 to the 4th. And that, let's see, 21, yeah, that does give me 81. So 81 I can rewrite as 3 to the 4th. Okay, bases are the same, so that means I must have y equals 4. Okay, down here I need to write 8 as a 2. 8 is the same as 2 times 2 times 2, which would be 2 to the 3rd power. Okay, some of these just take some guess and check, so you kind of just have to repeat, okay, what's 2 times 2? Well, that's 4. What if I add another 2? That gets me 8. Okay, that's 1, 2, 3. Okay, so if the bases are the same, then the exponents must be equal, so I get 3 equals x, or x equals 3. Okay, last couple examples like this. I want to write 64 as a 4, so it's 4 to some power. Let's see, 64, I could factor this. That's another way that you could look at this. 64, that's the same as 32 times 2. Actually, let's just divide by 4. That's 4 times 16. 16 is 4 times 4. So this is the same as 4 cubed. Okay, which tells us that x plus 1 must equal 3. I can subtract 1 to both sides, and I get that x equals 2. Okay, finally, 64 is the same as 8 squared. If I have 8 squared equals 2x, that means that 2 equals 2x. So I can divide both sides by 2. And these actually also kind of cancel out because 2 over 2 is just 1. So I get 1 equals x, or I could write it as x equals 1. Alright, the final problem, or type of problem that we'll have to deal with is when we can't change the base to make the sides match. So sometimes we have to change the base on both sides. Okay, for example, here I can't write this as a 9. Okay, 27 is 3 times 9, but that's not like 9 squared, right? It has to be like 9 squared, 9 cubed, and I can't do that. What I can do is break it down to a 3. Okay, it's the same as 3 to the 3rd power. So I could do 3 cubed. And I could break 9 down as well. This would be 2 3s, so I would write 3 squared. And then that's raised to the 3y power. Okay, so realize here, now we've created a power to a power. So make sure that you multiply these. Okay, so this is going to be 3 to the 2 times 3y equals 3 to the 3rd. Okay, 2 times 3y is going to go to 6y, which means that 6y must equal 3. So y equals 1/2. Okay, I'm a little out of space, so I'm going to rewrite that. Okay, same thing for this next problem. So I need to rewrite these. 32 I can't write as a 4. I could write it as a 2. I could break this down. It's 2 times 16. 16 would be 2 times 8. 8 is 2 times 2 times 2, right? I already know 8 is 2 to the 3rd, so I could just maybe try to recall or remember that 32 is going to be the same as 2 to the 5th power. And then 4 is going to be 2 squared, and then I make sure I put that in parentheses and include this exponent. Okay, again, I have a power to a power, so I'm going to multiply. This becomes 2 to the 5th equals 2 to the 2 times x minus 3. So I need to make sure I distribute this. Okay, so 2 times x minus 3 means I really have 2 to the 5th equals 2 to the 2x minus 6. Okay, that's because I'm multiplying to that, the whole exponent there. Okay, if that's true, that means that it must be that 5 equals 2x minus 6. Okay, the exponents must be equal. I can add 6 to both sides. I get that 11 equals 2x, divide by 2, and I get x equals 11 halves, or I could say 5.5. Alright, had to fix that one too for space. This next one here, again, I can't write 16 in terms of 8, okay? If I've just put 8 times 2 to the x, that doesn't help me because 8 times 2 is not the same as 8. Okay, I need it to be in the same base. So what I'm going to do here is put them both in terms of 2. Okay, again, I also can't do 4. Okay, this is 4 squared, but this is 4 times 2. Okay, so I can't put it with just 4 as a base. So the base that I need to use here is 2. 16 is the same as 2 to the 4th. 8 is the same as 2 to the third. Power to a power, so I have to multiply. I get 2 to the 4x equals 2 to the third. That means the exponents must be equal, so I have 4x equals 3. I can divide both sides by 4, and I get x equals 3/4. Okay, for this next one, 125 is not 25 squared. Okay, 25 squared would get me 625, but I can write these both in terms of 5. Okay, that's 5 times 25, which is 5 times 5. So 25 is 5 squared. 125 is 5 to the third power. Okay, so I'm going to write these in. So this is 5 to the third. This is 5 squared, and then it's being raised to the 6y. So I've got a power to a power, so I'm going to have to, oops, sorry about that. Power to a power, so I have to multiply on the right side. I get 5 to the 2 times 6y. So I have 5 to the third equals 5 to the 12y, which means that 3 must equal 12y. I divide both sides by 12 and get that y must equal 1/4. Okay, remember, if the bigger number is in the denominator, then your bigger number should stay in the denominator when you divide. Okay, looking at this next one, I can't write 27 as a 9. Did I already use those? Yeah, that was the same as our first one. So 9 I write as 3 squared. And 27 is 3 to the third. Okay, so x minus 1 is the exponent here. So I'm going to multiply, because a power to a power we multiply. So that gives me 3 to the 2 times x minus 1. I'm going to use parentheses there so I remember that I need to distribute that too. Okay, so this is 3 to the 2x minus 2 equals 3 to the third, which means that those exponents must be equal. Okay, I can add 2 to both sides. I get that 2x equals 5, and then divide both sides by 2 to get x equals 2.5, or you could leave it as 5/2. I guess I should box these. Alright, and the last ones are kind of like challenge problems, okay? Basically, they're just going to leave us with a little bit tougher equations, but it's not too bad. Okay, again, 9 and 27, I need to get those into 3 as the common base. 27 is 3 cubed. Okay, power to a power means we multiply, so I have got 3 to the 2 times 2x equals 3 to the 3 times x minus 3. Okay, I multiply these and I have 3 to the 4x equals 3 to the 3x minus 9, because I'm distributing that 3. Okay, so that means that the exponents must be equal. So I have 4x equals 3x minus 9. Okay, it's kind of why it's a challenge problem, I guess, because now we have x on both sides. So we'd have to subtract 3x to both sides. That cancels, and I get that x equals -9. Okay, sorry, kind of off the page there. Okay, over here, again, 5 is going to be my base, like this last one up here. So I have 125 is 5 cubed. Then to the 2x minus 1 is going to equal 5 squared to the 4x. Okay, power to a power, once again, we need to multiply. So this is 5 to the 3 times 2x minus 1 equals 5 to the 2 times 4x. Okay. Okay, when I distribute this, I get 5 to the 6x minus 3 equals 5 to the 8x. Those are equal, then it must be that the exponents are equal. Okay, now I've got an x on both sides. I take away the smaller one. I get negative 3 equals 2x. Divide both sides by 2, and I get that x equals negative 3 halves. Okay, finally, last one over here. I can't write 8 as a 4. Okay, it would be 4 times 2, which is not the same as 4 squared. So I want to write these both in terms of 2. So I have 2 squared to the negative 2x, and then this would be 2 cubed to the negative x plus 1. Okay, power to a power, we have to multiply those. So I get 2 to the 2 times negative 2x equals 2 to the 3 times negative x plus 1, which means that I have 2 to the negative 4x equals 2 to the negative 3x plus 3. Since those have the same base, then the exponents must be equal. So I have this equation. I could add either one. Okay, I'm going to add the 3x though, so that the x is just on one side and the number's on the other. So that leaves me with negative x equals 3. I divide both by negative 1, and I get that x equals negative 3.